Okay? So, magandang araw o magandang gabi. So, depende kung anong oras nyo to pinapanood na video. Okay? So, let's proceed sa ikapito nating example sa mechanics of deformable bodies. So, the same lang din. Galing ito sa libro ni Pytel and Q. Salaas na Mechanics of Materials 3rd edition. Okay? So, in this video, tatlo na yung natin example. So, ito yung ikapito nating example for the subject matter. So, sa hindi pa ikawalo pala. So, sa hindi pa nakapanood ng first 7 examples natin, you can find it somewhere in my list of videos. Okay, kindly see na lang. Okay, so without further ado, so simulan na natin yung example natin. So we have this question. Okay, so the lap joint is connected by 3 20 mm diameter rivets. Assuming that the axial load P is equal to 50 kN is distributed equally among 3 rivets, find A, the shear stress in rivet, B, the bearing stress between a plate and a rivet, and C, the maximum average tensile stress in each plate. Okay. So, nakikita natin na ito yung plate top view. And then, ito yung side view niya. Okay? So, una nating hanapin is shear stress ni rivet. Okay? Madali lang kasi kung titingnan natin, dalawa yung force magkabila, P. But for magkabilang panig, merong tatlong area. Okay? Ay, merong dalawang set ng areas. Okay? So, kahit titingnan natin dito sa taas, okay, tatlo yung rivets. Pag dito sa ibaba, okay, tatlo din yung rivets. Isa yung P. Okay? Normally, class, okay, dito sa solution, dinivide ko na yung kaagad yung P times sa area ng tatlong rivets sa shear stress. Bakit yung cross-sectional area ng rivets yung kinuha ko? Kasi ito yung shear area. Kung sinabi natin shear area, parang yung area kung saan kinikis-kis. Kasi yung shear is parang pakiskis siya na force. Okay? Parang yung stress na pakiskis yung shear stress. Okay? So here, supposed to be 2 times 50 times 10 to the negative 10 to the power of 3 Newton. And then, dapat 2 times 3 times pi over 4 times 20 squared 2. So, balit mag-cancel out naman yung 2 sa itaas at sa ibaba. So, therefore, pwede na lang natin sabihin P over 3, okay? The area of the 3 rivets. So, kinonvert muna natin yung 50 kilonewton to Newton para maging Newton per mm squared siya. Okay? So, we have 53.052 Newton per mm squared. And as usually, sa sinabi ko ng nakarang example, 1 Newton per millimeter squared is equivalent to 1 megapascal. So, yung sagot natin is 53.052 Newton per millimeter squared or 53.052 megapascals. Okay? So, para mas malinawan tayo, let's take a look at this, okay? Baka yung iba kasi sa inyo, nalilito pa, okay? Ito yung shear area na ibig kong sabihin, yung area ng tatlong rivets. So, yung bearing area at yung tensile area or yung normal area, magkaiba sila. Okay? So, let's proceed muna dun sa letter B. Okay? Yung tinatanong dito sa letter B is, ano yung bearing stress between a plate and a rivet. Okay? So, unlike dito sa sa letter A, na yung area, cross-sectional area ng tatlong rivets, iba yung ginagamit natin dito, but same lang yung force. Okay? which is P. Okay? But then again, dapat may times 2 dapat to. 2 times 50 times 10 to the third. And then may 2 to 2 times 3 times 25 times 20. Dahil tatlo dito sa ibabaw, meron din tatlo dito sa ibaba. But each of them nakaka-experience ng force na P. So, parang na-cancel out lang din yung 2 sa itaas at sa ibaba. Okay? So, ito yung area niya. Okay? So, sa shear area, ganito yung area, cross-section, parang yung force is kumikis-kis doon sa area, nagkukos ng shear stress. Dito sa ibaba, yung bearing area is parang, ito yung diameter, nasa taas yung diameter, tapos ito yung thickness ng plate. So, ito yung mga area na tinatamaan na nagkukos ng bearing stress, okay? D times T, okay? So, yung area mo dito is nagiging, okay, 3 dt, okay? 3 dt. Dito is 3 times pi over 4 d squared. Dito, 3 times d times t. Kaya ito yung ginamit natin, okay? Ito yung, okay, nabaliktad lang. Ito yung d natin at ito yung thickness ng plate. Isang plate lang. Kasi isang P lang din yung ginamit natin. Times 3, which is 3 areas, okay? Yan yung area ng bearing. So i-divide natin. So, nakuha natin yung sagot na sa bearing stress, which is 33.33 Newton per mm squared, or we can say it is 33.33 megapascals. And then, we have the last. Yung tanong is yung tensile, maximum average, okay? Maximum average tensile stress in each plate. O, eto yon. So, ganun pa rin, isa lang din yung P natin, pero yung area iba na. So, unlike sa shear, ito yung cross-sectional area. Ito yung, ang area na to ay hindi na to cross-sectional area, para ito yung perpendicular area. Okay? Yun sa shear, parallel area, dito, kasi pag sabihin natin tensile, ibig sabihin, normal stress siya na away from the body yung reaction. Okay? So, ito yon. Okay? Meron tayong, dito muna tayo. Di ba meron kang 130 dyan? Okay? Ito. And then, ito yung diameter. So, may butas. So, i-minus mo yung 130 dito sa diameter ng butas. I-multiply mo dito sa thickness ng, ng plate. Parang ito ba, para mas malinaw. Ito yung tensile area mo. Okay? We have the normal area. So, dito yung force. Pag ganyan, no? Paharap sa'yo yung force. So, ito yung width mo na 130. Galing dito. Ayan, galing dyan na 130. Minus. At ito yung rivet. Isa lang yung rivet natin kasi nakalinya sila pag ganun, papasok. Okay? 130 minus 20 at meron kang thickness na 25 mm. So, sa isang plate lang. Anyway, dalawa lang naman yung P at dalawa din yung plate. So, magka-cancel out 2 divide 2, 1. So, parang wala kang minultiply. So, ito yon. So, therefore, the tensile stress is equal to 50 times 10 to the 3 over 130 minus 20 times 25. So, ito yung bearing, yung tensile area mo. So, therefore, makukuha mong sagot is 18.182 megapascals. Okay? So, ayan yung, ito yung, ito yung question, at ito yung solutions natin. Okay? Ayan, pakita ko sa inyo na para may emphasis. Ayan. Okay. So, and then, dahil video naman ito, so yung advice ko sa inyo, pwede nyo namang i-post yung video. And then, para matingnan nyo ng mabuti yung example. At saka pwede nyo ring makopya. Pwede nyo isulat sa inyong notebook para meron kayong reference. So, depende na yun sa inyo. Okay? So, and then, let's have our second example in this video and our 9th example. Okay? for mechanics of deformable bodies na nandito sa, okay? So, ito yung, ano natin, ito yung question natin, no? 1.36. So, this is our 9th example, okay? So, the bell crank, which is in equilibrium under the forces shown in the figure, is supported by a 20 mm diameter pin at D and is double shear. Okay? Determine the required diameter of the connecting rod AB given that the tensile working stress is 100 megapascals and the shear stress in the pin. Okay? Dalawa yung hinahanap natin. Una is yung required diameter of the connecting rod AB and then shear stress in the pin. Okay? Okay, so ito yung solution natin. Gagawa tayo ng free body diagram. Ibig sabihin, tanggalin natin yung mga supports. Ito lang yung supports D. Okay? Ito lang yung matatanggal. Okay? So, dx and dy. Okay? Pwede kang mag-assume na the other way around yung direction ng forces mo, whether vertical or horizontal. Pero, para sa akin, ganito. Nag-assume ako na pataas yung si dy at going to the left, going to the right si dx. Anyway, kapag yung nakuha mong sagot is negative, ibig sabihin, yung inassume mo, kabaliktaran nun yung actual. Okay? So, ito yon. So, and then again, just like our statics, pwede i-apply natin yung static, yung equilibrium equation. Static equilibrium equation. Okay? That's here. Okay? Yung una kong sinulat is yung summation of forces along horizontal. Okay? Baka magtanong kayo, dapat bang unahin ng forces along horizontal? Okay lang yan, magkalipat-lipat sila ni forces horizontal, forces vertical, at moment at any point is equal to 0. Okay? Nakadepende yan sa inyo. Makukuha mo pa rin ang sagot kahit magkabaliktad-baliktad yung pagsulat mo. Baka unahin mo to before ito at ito naman, okay? So, ito yung gamit ko, summation of forces along horizontal. Pwede ring i-x mo to, depende yan sa'yo, okay? So, we take all the horizontal forces in this figure. So, we have horizontal force P and dx, and then the x component of this 30 kilonewton force, okay? So, we have negative P. Bakit negative P? Kasi nag-assume tayo na positive to the right. Ito to the left to, sa kaya negative P. Yung dx naman is to the right na siya. So nag-assume tayo na positive yung to the right, so positive siya. So negative P plus dx minus 30 cosine 60. Okay? Bakit naging negative 30? Kasi yung x component niya, i-imagine niyo parang ganito, oh. May x component, okay? So, yung 30 kilonewton, parang ganito lang yan, eh. Okay? Para mas maintindihan natin, baka yung iba sa inyo, laging nagtatanong, okay? Ito yung 30 kilonewton natin, di ba? Okay, ayan. So, pag kinomponent mo siya, yung y component niya is ito. Okay? Yung x component niya is ito, okay? And then y comp niya is ito, okay? Yan, no? So, pag ganito, yung x component mo is going to the left. Kaya, okay? Negative, okay? Negative cosine 60. Bakit? Ang yung x-axis is adjacent dito sa angle. Okay? Sana naalala nyo yung trigo nyo. Okay? Sana hindi kayo namayabas. Kung sa Bisaya pa, namayabas during lecture. Okay? Yan. And then we have another equilibrium equation. O summation of forces vertical is equal to 0. So, titingnan natin yung mga vertical forces dito. Okay? Halata naman yung dy. Okay, itong dy, oh, vertical, at yung y component nito is pababa. So, si dy mo is positive, yung y component ng 30 kN is negative. So, ito, dy minus 30 sin 60. Okay? Bakit sin 60? Kasi yung y component mo is opposite to 60 degrees. Kaya, sin 60. Kasi opposite siya dito sa, yung y component is opposite to the angle, 60 degrees. Kaya ganun, okay? So, we have, okay, pwede nating i-transpose. So, makita na natin kaagad yung value ni dy, which is 25.981 kN. And then again, pinili ko kasi meron ng tayong value ng dy. So, again, we can sum forces at D para makita natin yung value kaagad ni P, okay? So, ibig sabihin, pag nag-sum forces tayo at C, at D, ibig sabihin, itong D, magiging, imagine niyo uli na steady ito and the rest of the forces will make the body rotate relative to this point. O sige, imagine niyo, ito yung point na, kumbaga ito yung fulcrum, and then yung iba nagkukos ng rotation. So, ito si P, nagkukos siya ng rotation. Imagine niyo, parang nagro-rotate siya patungong nagiging counterclockwise. So, again, dito, nag-assume tayo na counterclockwise yung positive. So, therefore, yung P mo is positive. And then, i-multiply mo dun sa perpendicular distance niya mula sa point. So, this is the direction of the force, P. Okay? Pa-counterclockwise yung galaw niya relative dito sa point. And then, yung perpendicular niya na distance from that point is 200 mm. Okay? Take note, perpendicular distance, hindi parallel. Okay? And then again, dito tayo sa y component ng 30 kN. So, yung 30 kN natin, y component is 30, negative 30 sin 60. Yan. Okay? So, ibig sabihin, negative 30 sin 60, i-multiply mo dun sa, yan o. Okay, sorry. Nahulog yung cellphone ko. Okay. 30 sin 60. Okay. Negative 30 sin 60 times 240. Kasi yung 240 natin, okay, 240 yung, okay, yung perpendicular distance ng y component ng 30 kN force natin. And this 240 mm is measured from the point we are having summation of forces with. Kasi nag-summation of forces tayo mula sa D. Magsukat ka ng perpendicular distance patungo dun sa point kung saan nangyari yung 30 kilonewtons. So, 240. Kaya ito 240, okay? Sana naalala nyo yung statics natin. Okay? So, we have 31.177 kilonewton. Okay? So, since meron na tayong value nito at ng dy at saka ni P, pwede nating substitute kay equation number 1. Okay? Ito sa equation na to. Ito yung nangyayari. Okay? So, sinubstitute natin P, negative P plus dx equals 30 cosine 60. Okay, naging 31.177 plus dx equals 30 cosine 60. Okay, kasi may value na tayo ni P. Ito. Ayan. To the left. To the left siya. Kasi yung sagot dyan is negative. Kaya to the left. Negative 31.177 plus dx equals cosine 60. Then, lipat mo dyan. So, yung force mo is literally 46.177 kilonewton to the right. Positive siya. Dito, actually, may nalimutan akong step. Dapat, meron pa tong P is equal to negative 31.177 kilonewton. Okay? Yan. And then again, dahil negative siya, yung dito sa ano natin, nag-assume tayo na to the right, so babaliktad siya. 31.177 to the left kasi negative. So instead na to the right, to the left siya. Okay? Pero dito, pag substitute natin, gagamitin natin yung original niya na value, negative. Hindi ito. Itong negative ang ilalagay natin. So, and then again, makukuha na natin yung resultant at D by having anong tawag dyan? Pythagorean theorem. By Pythagorean theorem, dx squared plus dy squared. Okay? So, yung dx natin, ito. Yung dy natin, ito. Itong value. Okay? Ito at ito. Yung dy. So, makukuha natin yung sagot. Ang sagot natin is 52.984 kilonewton. This is the reaction at D. Okay? So, next, ito na yon. Hinahanap natin yung minimum diameter at AB. Ito. Required diameter o connecting rod. Connecting rod AB. Ito. So, ano yung diameter? So, matatandaan natin na yung force at AB, okay, is itong P yung nag-a-act. So, therefore, yun yung, ang value ni P ang gagamitin natin na force and then over sa cross-sectional area nitong AB, okay? Ito, oh. So, DAB, hindi natin alam. Okay, sorry. So, DAB, hindi natin alam anong value. So, i-substitute natin, okay, stress at AB is equals to PAB over area of AB. So, where AAB is equal to pi over 4 DAB squared, okay? So, alam naman natin na yung tensile working stress according sa given is 100 Newton per mm squared or 100 megapascals. Is equivalent to yung nakuha nating sagot ni PA sa P. Actually, si PAB is equivalent to P. Ito, oh. Yan. Ayan yung na-compute natin na P. Okay. So, yan yung gagamitin natin. Equivalent siya sa force ni PAB. Okay. So, substitute. Okay. Then, okay, over pi over 4 DAB squared. Ilipat mo doon. Okay. Pwede natin gamitan ng simple algebraic manipulation or by using your calculator, we can get 19.924 mm. Ito yung minimum na diameter at pin AB. Okay? So, again, the last one is hinahanap natin ang shear stress and pin. So, nasan dito yung pin? Yung pin natin is nakay D. Okay? So, ito, okay? Review natin. Yan, D. So, double shear siya. So, ibig sabihin, pag sinabi nating double shear, hindi yung doble yung force niya, doble yung kakaltasin na force. So, meron kang force dito. Okay, dalawa yung area. Sa left at sa right na area, cross-sectional area ng pin. Kaya, doble yung area ng pin mo. Area dito, at area dito, sa magkabilang panig. So, dalawa. So, kaya, para makuha mo yung, stress sa pin, shear stress sa pin, so, RD divided by the cross-sectional area of the two pins sa magkabilang panig. Okay? So, 52.984 times 10 to the third. Okay? Alalahanin natin, pag naka-kilonewton siya, i-multiply mo muna sa 1,000 or 10 to the power of 3 para maging newton. So, i-divide mo sa area, ito yung sagot. 84.971 megapascals. Okay? So, that is our second example for this video and ninth in our subject matter na na-upload ko dito sa channel. Okay? Yan. Yan yung 9 question, okay? Dahan-dahan natin, and then yan yung pinagdaanan nating solution. Okay? Yan. Ayan. Okay. May erasure na yan eh. Okay, ganito. At ito. Okay? I-post nyo lang para makita nyo yung malinaw yung solution. Pwede nyo kopyahin by hand. Pwede nyo ring i-upload itong video. Okay? So, let's have our last example for this video. Okay? We have, and the 10th example as a whole para sa subject matter natin. So, ito. So, 1.38. The right angle bar is supported by a pin and B at a roller at C. What is the maximum safe value of load P that can be applied in the stress in the pin is limited to 20,000 psi. So, the 3/4 inch diameter pin is double shear. Okay? Double shear na naman. So, doble yung area niya. Left and right. Okay? So, as usual, isulat natin yung free body diagram niya. So, ito. Since pin to at ruler to, okay, naalala nyo pa ba yung reaction? Pag ruler, ito yung ruler mo, perpendicular reaction lang yung meron relative to the ground. At ito naman, basta pin, meron kang reaction vertical at horizontal. Actually, nag-assume ako ng direction. Pero depende yan sa inyo anong trip nyong assume direction. Basta negative siya, ibig sabihin, the other way around yung direction ng force. Whether horizontal or vertical. Okay. So, yung inuna ko dito is nag-sum of forces ako at C. Para makita ko yung value ni P. Okay. Dito ako nag-summation of moment. Okay. So, as usual, iset natin, pag nag-summation of forces ka at a certain point, iset mo siya as parang fulcrum o parang steady na point, okay? Pag steady ito at lahat ng forces, the rest is lahat ng forces nakapalibot sa kanya is causing the body to turn around. So ibig sabihin wala itong kwenta itong CY, wala siyang effect sa moment at C. So ito lang yung may effect, si BY, kasi meron siyang perpendicular distance. Si BX, 0 yung perpendicular distance niya kasi parallel siya dito eh, di ba? So negative 12 BY. Bakit negative 12? Kasi nag-assume tayo na positive yung moment. Pwede ring mag-assume ka na yung clockwise yung positive at hindi yung counterclockwise yung positive. Dito, counterclockwise natin yung positive. So, dahil nag-assume tayo na counterclockwise is positive, so therefore, itong BY, since fulcrum to, it will tend the body to rotate clockwise. So, negative BY times the moment arm 12. Okay? Plus sine 30 times 12. Okay? Bakit? Kasi, let's talk about P sine 30, ito yung Y component ng P. So, meron siyang Y component na ganito. Okay? Pababa. Mula dito sa A, pababa. Parang ganito. Okay. PY is equal. And then, meron tayong PX dito. Okay? So, ito na yung lang. Okay? Para mas malinaw. So, yung PY na component is equivalent yan sa P times sine 30. Kasi, parallel siya, opposite pala siya dito sa angle na 30. So, P sine 30 times the moment arm na 12 din. 12. Okay? Kaya ito 12. Then, minus the horizontal component of P, which is PX. And PX is equivalent to, okay, P cosine 30. Okay? Para mas malinaw. And then, P sine 30. Ayan. Para mas mag-gets nyo. Okay? Ganon. So, negative P cosine 30 times 10. Kasi yung perpendicular distance niya is itong 10, oh. Px, then ito yung perpendicular distance niya relative to C. Yan. So, nakuha natin na si By is, ito yung value, negative 0.22168786P. And then, again, okay, nakuha natin yan. So, or equivalent to By is equal to 0.22168786P. Kasi negative eh. Then, nag-assume tayo na upward siya, pero negative siya. So, pababa pala yung By natin. Ganito. Okay? So, and then again, let's have meron tayong another equilibrium equation. Summation of forces along horizontal equals 0. So, P cos 30 minus Bx equals 0. Okay? So, Bx is equal to P cosine 30. Okay? Ito, summation of forces horizontal. So, yung horizontal natin, itong Px, which is equivalent to P cosine 30. So, P cosine 30, at yung isa nating x-component na force, may x-component na force is itong si Bx. So, Bx, lagay mo Bx, minus kasi to the left siya. Then, nag-assume tayo to the right yung positive. Ito lang yung positive si Px. So, at i-transpose mo yung Bx dito, okay? So, magiging Bx equals P cosine 30 degrees. Positive, kaya sakto yung assume natin na to the left yung direction niya. Ayan, okay. So, forces vertical, yung vertical naman yung isa-sum up natin. So, meron tayong P sin 30, pero pa-down siya eh. So, instead na up, so negative. So, meron tayo By at saka Cy. I-add natin sila lahat ng vertical components ng force. So, and then, i-ano natin, i-substitute natin. Yung original yung i-substitute natin na nakuha ang value. Kung negative, negative talaga. So, negative, ilagay natin dito sa By plus, so, na-substitute na siya. So, Cy minus P sin 30. Okay? Bakit sin 30? Kasi ito yung Y component ng P. P sin 30. So, nakuha natin na si Cy is 0.72168786P. Positive, kaya yung assumption natin na pataas siya is tama. Kaya, ganun. Okay? So, without, ito yung, ano niya, karugtong niya. Kasi, hinahanap natin yung RB, di ba? Hinahanap natin yung, para makita natin yung resultant ng forces at B. So, Bx squared plus By squared. Okay, so si Bx, alam natin from, is equivalent to P cosine 30. At ito namang si By is 0.22168786P. Okay? Yan. So, then again, ito yung RB mo. 0.893949381, okay? Baka magtanong kayo, bakit mo dinamihan yung decimal places, sir? Okay, ginawa ko to para mas accurate yung sagot natin. Okay, pwede nyo na ding i-round up into 4 or 5 decimal lang para hindi masyadong ambiguous. And then again, let's go to the stress equation. So, ang stress na hinahanap natin is yung kay sa pin. So, yung pin area natin, previously, baka nakalimutan nyo, is nasa kay B. So, kay B tayo. Okay? RB over AB. So, yung allowable stress at B is 20,000 pounds per square inch is equivalent to, okay, yung value ng RB is ganito, 0.893949381P divide sa twice the area. Okay? Kasi double shear. So, merong area sa magkabilang panig. Dalawa yung niya. Okay? So, kaya 2 times pi over 4 times 3/4 squared. So, nakuha natin na P is equal to 19,767.852 pounds. Pwede nating i-rewrite to as 19.768 kips. Okay. Yan. Pwede mo ring sabihin na kips. 19,767.852 pounds or 19,000.768 kips or kilopounds. So, I hope, okay, I hope na may natutuhan kayo. Okay? So, uulitin ko, this is our last example for this video. Oh, ayan. Yan yung question. Yan yung figure. Yan. Yan yung solution. Dahan-dahanin natin. Yan. Okay. Yan. Then, ito yung karugtong niya. Okay. Pasensya na. If may mga erasures. Ayan. At ayan. Okay. So, hanggang sa muli. Hanggang sa susunod na example. Okay.